So where I got this question from, interestingly, was my son's 4th grade math class. I loved it. He brought that home. I was like, this is calculus. Did you know that? He's like, oh, okay. So what I'd like for us to do is read what's going on here. We have time and we have speed. And it's about a racer doing a race. And actually, you know what? I changed my mind. I'm going to hit pause and have you guys try this front page, and then we'll go over it together. I'm going to hit pause. All right, so I'm looking for a letter like A, B, C, D, E, F, G. When is the racer speeding up? There's 2 answers. Good. Cool. All right, when is the racer stopped? There's only 1 answer. E. When speed is 0. All right, when is the racer going at a slow, steady speed? So it should be flatlined. I would say G. G is the slowest one there. That's a steady speed. I don't know why that line goes on to the next line. That's weird. All right, what's happening at D? Slowing down. Yeah, now that is a subtle difference. This is a speed graph, not a velocity graph. And we're going to talk about that. Okay. Again, I got this from a 4th grade classroom. What is happening at F? Speeding up. And at C, constant speed, fast or slow? Fast. So a fast, constant speed. Now, I don't think we necessarily need to write anything here, but let's just have a quick conversation. Can anyone make up a story of what happened? Like, what's going on here? He's cruising, and then he speeds up, and he's like, oh, I'm cruising, I'm doing really, really good, and then, oh, he's a racer. Oh, there was a curve, but should you stop during a curve? Oh, pit stop. Okay, pit stop. They did a good pit stop because it doesn't seem like a real long time. Speeds up, and then he's cruising again. Oh, I was thinking of a car. Okay, let's pretend it's a person running. So they're running along, they speed up, they've got a lot of stamina, they're running. Then what happened? They fell or they got a water station. So they stop and they recover or they take a drink. They start running again and then they're cruising. Okay, cool. Do you understand what's going on? Now this next part is going to be like the notes. Okay, so you're going to have to stick with me on this. I usually get told, a lot of people that have done physics, I've already written this down. Write it down again. All right. Position is S of T. I'm really not sure why that is. I think P for position would make more sense. But that is just where the particle is. Where the particle is position. And let's talk about that word particle for a second. Particle, because usually people will think of like a dust speck. Particle just means a thing with motion. So your particle could be a car or a person or an airplane. The particle is just the thing that's moving. Okay, it's not like a speck. Do you get what I'm saying? Not like an atom or something. Now, an example, it's not always feet, but an example of units would be feet or meters or yards, but just like the amount. All right, velocity of V is V of T. That's the derivative of position. And so that is the particle's rate of change. Per something else. So an example would be feet per second, or thank you, miles per hour, meters per day. You know, you have to read the question, don't make it up. It's whatever it is. So we're going to talk about what happens when the velocity is positive, when the velocity equals 0, and when the velocity is negative. So if your velocity is positive, your particle is moving in the positive direction. Now that can mean a lot of different things depending on the context of the problem. It could mean moving forward. It could mean moving to the right. It could be moving up. It could be moving away from a starting point. But you have to read the question. What's going on if your velocity is 0? Not moving, which we call at rest. They'll say, when is the particle at rest? So not moving, stationary. It's like you're at a red light. And if the velocity is negative, moving in a negative direction, which could mean to the left or backwards or downwards. You know, it depends on the context of the problem. Bless you. All right, acceleration is a of t. That's the derivative of velocity, which is the second derivative of position. Can I ask you a quick question though? So in physics, someone's probably told me this before, but I forgot. There are people in physics that haven't taken calculus. So how do you do acceleration without a second derivative? Like if you don't take derivatives, how do you get it? There's like a different equation? Oh, is it annoying? Oh, this is way easier than that. Oh, okay. All right, cool. That is a rate of change. So you could say the rate of change is increasing or the rate of change is decreasing. And so what would be an example of units for that? Going with like I had feet and then feet per second, it would be feet per second squared. It's per second. So per second squared. And we're going to talk about what happens when acceleration is negative, 0, and oh, sorry, let me do positive first, then 0, then negative, because that's how I did it with velocity. Positive, 0, negative. Acceleration is the pull. It's how you're being pulled. So if your acceleration is positive, you are pulled in the positive direction. It doesn't necessarily mean you're going in the positive direction. For that, you would need to look at velocity. You're being pulled in the positive direction. What does it mean if your acceleration is 0? Constant velocity. So that is like cruise control. You aren't stopped, you're moving, but at a constant rate. And if your acceleration is negative, you are pulled in the negative direction. It doesn't mean you're going in the negative direction, though. For that, you would need velocity. Here's the example I always use. Pretend you're in your car, you're driving down 360. You're moving forward. What kind of velocity do you have? Positive. You see a red light and you hit the brakes. Do you immediately start going backwards? No. You still have positive velocity. You just have negative acceleration. Speed is the absolute value of velocity. Your speedometer in your car does not go negative. And this is the most commonly missed thing, is the speeding up and slowing down. So maybe put stars next to this. Speeding up and slowing down is the most commonly missed thing, and they will ask it. Speeding up means your velocity and acceleration are the same sign. I'll give you a positive and a negative example. If you are going forwards in your car, that's positive velocity. And if you're pressing on the gas pedal, that's positive acceleration. So you're speeding up in the positive direction. But they could also both be negative. If you jump out of an airplane, you have negative velocity. Gravity is pulling you down, so you also have negative acceleration. You are speeding up negatively until you pull the parachute, hopefully, right? Slowing down would mean velocity and acceleration are what? Well, speeding up would mean they're the same sign, so slowing down means opposite sign. And that's like the example I just gave. If you're in your car and you're on 360 and you're going forward, that's positive velocity. If you hit the brakes, that's negative acceleration. You're still going forwards, but you're slowing down. Cool. Now, sometimes people will get that right, and they'll say velocity and acceleration are the same and leave off the word sign. They won't give that to you because are they the exact same thing? No, same sign. Or they'll say they're opposites. No, you have to say opposite signs. So just be careful about that. All right, that's essentially the lesson. I mean, that's it. We're just gonna practice the heck out of it.
If you finish one question about speed, would you justify it by saying it's speeding up if they're at the same time?
Yes, but you can't say they. You have to say velocity and acceleration. Yes, actually, if I should just do these out of order. You know what? I think we can do 1, 2, and 3. I'll see if we can do 1, 2, and 3. I'm fine with doing the other ones next time because we needed to go over the test, but I want to see if we can do 1, 2, and 3. So stick with me. All right, bless you. So this is what you're given. Were you given position, velocity, or acceleration? Position, and we have seconds and we have feet. So just be aware of what's going on. Find velocity and acceleration functions. All right, guys, what's your velocity function? Good, which would be 3t squared. Good. They're not all going to be really hard. Sometimes they give you one like that. All right, acceleration would be the derivative of that, 6t. They typically don't give you functions that are too terrible for this.
So what did you?
I did the derivative of velocity. It's just second derivative. All right, when is the particle at rest? That's when your velocity equals 0. And I'll tell you what, occasionally on the free response part, if they say when is the particle at rest, you will get 1 point for writing that. And then like the next point for actually getting the answer or whatever. All right, so we're going to take our 3t squared minus 3, set it equal to 0. Welcome back to algebra class. What would you do to start solving that? Add 3. Divide 3. Square root. Now you'd get plus and minus 1, but we don't do negative times, so 1 second. Now we're going to practice filling in the chart because a lot of times they'll say, what is the velocity at time 2? So you just get the velocity and plug in 2. So being able to plug in numbers is important. All right, so let's do position. What do you get if you plug in 0 to this position function, the original one? 2, good. I'm hoping this part doesn't take forever. All right, if you plug in 1, is that 0? 1 minus 3 would be negative 2, plus 2 would be 0. All right, if you plug in 2, 2 cubed, 8 minus 6 would be 2, plus 2 is 4. All right, now velocity. So we're going to plug 0, 1, and 2 into this one. So what do you get if you plug in 0? Negative 3. Real quick, that means the particle is moving what direction? So left or downwards, or I think this is left and right, so we would say left, okay? Plug in 1. Oh, we already kind of did that. At 1 second, particle at rest, not moving. And if you plug in 2, 2 squared is 4, times 3 is 12, minus 3, 9. Good. That's positive, so the particle is then moving to the right. So if it was moving to the left and then moving to the right, what does that mean it did? It changed direction at some point. That's another thing they ask a lot. When did it change direction? All right, and then acceleration. We're going to plug in 0, 1, and 2 right here. So 0 would just give you 0. 1 would give you 6. 2 would give you 12. Those are all positive, so it's being pulled in the positive direction. So let's draw a number line showing where the particle is. So we're going to look at position. I'm going to cover these up. The position at time 0 was 2. Now I just draw a circle. You can put whatever you want. A star, a heart, an elephant. Remember, a particle can be anything with motion. All right, then where does the particle go? 0. This is just to give you a visual of what's going on, because the last part here is how far did it go? So you got to be able to add up the motion. All right, and then where does it end up? 4. That's just a visual. That's to help you see and understand what's going on as it's moving left and right. So actually, let me jump down to F, because that's the whole point of doing this. What's the total distance that it went? Well, it goes from 2 to 0. That's a distance of 2. Plus, then it goes from 0 to 4, which is 4, so 6 feet. You're just adding up the motion. You guys hanging in there with me? I even gave you candy. You got to make it till lunch. You got like 20 more minutes. Yes, later. Actually, there might be one on here that says that. But that's a huge thing. But we do that with integrals. So just hold on to that. All right. So write a description. I'm not going to write like a whole paragraph. We're just going to say what like direction it's going. So it goes from 2 to 0. And the velocity is negative. So I'm gonna say goes from 2 to 0. The velocity is negative, but the acceleration numbers in between 0 and 6. We're talking about what happened in between here. So it goes from 2 to 0. Velocity would be negative in between there. Acceleration would be positive. So if those are opposite signs, slowing down. Which makes sense because what does it do once it gets to 0? Stops. So stops at 0, which also makes sense because that's where it turned around. And so then it goes from where to where? 0 to 4. Oh, why speeding up? Good. Velocity is positive between 0 and 9. Acceleration is positive. Good. That went well.
So.
I can definitely finish the next two before lunch and we'll stop there.
Section 2 draw the number.
How did I know where to draw this?
Yeah.
I just looked at the positions. It started at 2, so I put it at 2.
Okay, so
It went to 0, so I put it to 0.
And you moved it to the-
Yeah, I actually didn't even really look at any other numbers besides 2, 0, and 4.
I just didn't understand.
Hey guys, that was a really good question. Did you hear that? Like knowing what numbers to put on here? I didn't really look at anything besides this row. It started at 2, it went to 0, and then it went to 4. Those are the only numbers you really need to look at. It's just where the particle is. Oh, cool. This one, they give you a graph. Please read though. What is that the graph of? Is it position, velocity, or accelerated velocity? Circle that. That's velocity. And I'm going to write something off to the side here that is going to be super helpful. And you're going to write it like at the top of all your papers. I want you to write position, velocity, acceleration. Where position is increasing, velocity is positive. We talked about this when we matched up the graphs with their derivatives. Do you remember the envelope activity and you matched them? We're just now calling it position and velocity. It's a derivative. Increasing positive, that means decreasing. Do you remember above sea level, below sea level? It's that. You have new vocabulary, but that's it. Now, if that's true from here to here, it's true from velocity to acceleration. So increasing positive, decreasing negative. I usually tell students to get a sticky note and put that on a sticky note and just transfer it with them to everything that they do. That way you don't have to write it over and over again. Go ahead. I don't know. I said that when I started. It messes me up too. It's S. I don't know.
And I think speed.
Speed, but see, velocity and speed are not the same. Okay, so letter A. And I don't think there were units on this, right? Did you see seconds or feet or anything? No. Okay, so if there aren't any, don't invent them. Just don't put anything. So at what time? Oh, it says speed, but this is velocity, so be careful. At what time, so we want a t equals something, is the speed the greatest? I want you to guess, like give it a guess. Nope. Nope. Why is it 8? But remember, speed is the absolute value of velocity. So time 8. That's when it's furthest away from the x-axis, if you want to think of it that way. All right. Now, at which of these times is acceleration the greatest? Explain your answer. Our justification is going to be that we're going to find them all and just pick the one that's biggest. This is called a candidates test. If you test all the candidates, that's your justification. We tried them all and we picked the biggest one. Now, acceleration, look at our handy little chart here. We're looking at velocity, but we're being asked a question about acceleration. All right. Increasing positive, decreasing negative. Derivative means slope. All right. So at 2, what is our slope? Like if you draw in a tangent line. Okay, so that one's 0. At 6, count the little boxes like algebra 1 style. Yep, -3, the halves, good. Thank you for not saying 2s. All right, and then at 9, what is the slope of that part? Yeah, 3. So at time what is the acceleration the greatest? At 9. And this is your justification. You tested them all and you just saw which one was the biggest. All right, over what time interval, so it's going to be from this time to this time, is the particle moving to the left? That would be when velocity is negative, so below sea level. Maybe write that out. Moving to the left, velocity is negative. V of t is less than 0. Or you can write is negative if you like that better. Where is this graph below sea level? 4 until 10. Time 4 to time 10. Oh, and it said explain. This is your explanation because velocity is negative. That's the explanation part. Sometimes I like to put the explanation first because then it helps me look at the graph. All right, over what times is, okay, this is the hard one. Speed decreasing. And let's do the explain first. Speed decreasing means velocity and acceleration are what? Opposite, thank you, signs. Opposite signs. Sometimes it's easier to put the explanation first. So you're going to have to watch me point to the graph because I don't have a better explanation than, hey, look, okay? So look at this first section. Let me zoom in. From here to here. Is the graph above sea level or below sea level? It's above, and it's also increasing, which means acceleration is positive. So during this time, velocity is positive and acceleration is positive. Do we want that part? No. All right, from here to here, it's above sea level, so velocity is positive, but acceleration is negative. Do we want that part? Yes. Okay, so from 2 to 4, that's like one part. I'm going to write it as an interval. 2 to 4, and then union, there's going to be another one. Just hold on. You can write from t equals 2 to t equals 4 as well. I was just trying to shorten it. All right, look at the next section. Where is this part of the graph? Where does it live? Negative, so that means velocity is negative. Now, one second. It's also decreasing, which means acceleration is negative. So they're the same sign. Do we want that part? No. All right, from here to here, what's going on? Velocity is what? Where is the part of the graph? Below. That means velocity is negative, but it's increasing, so acceleration is positive. So where is that from? Where to where? 8 to 10. And then do we want the last section? No. What is velocity there? And acceleration? Positive. I just wanted to finish the thought before, if you think of it, say it again, okay? Now, a lot of people will do this. They're opposite signs when you're moving away, or sorry. They're opposite signs when you're moving towards the x-axis. So like this part and this part. And they're the same sign when you're moving away from the x-axis. If you want to think of it that way, that's fine. They will not accept that as an explanation. You cannot go because moving away from x-axis. You have to say this. So if you want to think of it that way, that's fine, but don't write that on your paper. All right, this last one we're going to do is calculator. I'd like for you to just follow along with me. All right, for the sake of time, I'm going to go ahead and type this in. What is the equation? Oh, no, I know it says t cubed, but I'm still going to type x. Okay, so let me zoom back out here. All right, so x to the third, then what? Minus 4x squared plus 6. Did they give a window? Yes. So watch. I'm going to hit window right here. I'm going to make my x's 0 to 4. You can fiddle with the rest of it if you want, but negative 10 to 10 is good. So let's just go with that. We can change it if we want to, but I think we'll be able to see everything. There we go. Now let's read the problem. What is this about? A hot air balloon in kilometers per hour and how it's moving. Assume the balloon is initially where? On the ground. That's so you can get in. But people will look at this and go, oh, the balloon started up in the air. No, this is not position. What is this a graph of? And how do you know that from what it said? Rate of change. They use R for rate. But hey, if that bothers you, change it to a V to remind you, hey, that's velocity. Now let's see what's going on. And I'm going to point to it on here instead of up there so it shows up in the video. Where is this part of the graph? Above or below? That means the balloon moves. Above means positive. That means up. Let's try again. Where is this part of the graph? Above. That means velocity is positive. That means the balloon moves up. That's good because if it starts on the ground, can it go down? No, it isn't going to burrow into the ground. Okay. So the balloon starts on the ground. For this positive part, it moves up. For this negative part, it moves down. And then for this positive part, it moves up again. Should you exit the balloon at the end of 4 hours? It's not advisable. Why not? It's in the air. It just finished moving up. Okay. So it starts on the ground. It moves up. It moves down. It moves back up. Are we all together? I hope so. All right. For what value of t is the altitude decreasing? That would be from whatever this is until whatever this is. Velocity is negative. How can I get my calculator to give me those times? Where am I going to go? It's one of these. What does it say above trace? Good. Calc. So I'm going to do second trace. Which thing do I want? Okay. Well, 0. And then you're going to do left bound, right bound, guess. I don't like fiddling with the arrows. Do you see how this looks like it's around 1.5? All right. So for left bound, I'm going to hit 1 enter. For right bound, I'm going to hit 2 enter. And for guess, I'm going to put 1.5 and it will tell me. How many decimal points? 3. Write that down. T equals 1.571. 2. And then I need to get the other one. So I'm going to do that again. Calculate 0. What am I going to put in for my left bound, right bound guess this time? Good. 3, 4, anything between 3 and 4, but 3.5. There we go. 3.514 hours. It didn't ask to explain, but I'm going to ask you, why did we pick those times? They will not give it to you if it's it. I know that sounds like I'm being so hateful. If you say it, they won't give it to you. What is this the graph of, guys? Velocity is negative. Velocity is negative. All right. Find the value of r prime of 2. Oh, we're going to learn something here. If you're allowed a calculator, should you do any derivatives by hand? No. How are we going to type this? Math 8. Here we go. Math 8. d dx. What goes in here? The function. All right. So t cubed. I'm going to type x. Minus 4x squared plus 6. This would be an easy one to do by hand, but why would you bother? Right? And then what am I plugging in for such that 2? Go ahead. Put 3. Oh, you can actually put -4 for that. All right. So -4. And then it says explain what it means. R was velocity. So R prime is acceleration. Do you see how this is negative? That means the rate is doing what if it's negative? Decreasing. -4, what units? Kilometers per hour squared at, you have to say one more thing, time 2 hours. You guys are good on that. Do they make you do that in physics too? At time, whatever. Okay. If you write the whole thing, but don't put at time 2, they won't give it to you, which I think is rude. But no. All right. When is the balloon closest to the ground? Let me bring the graph back up. Can you guys all just look? Starts where? On the ground. And then it moves up. And then it moves down. So it's closest to the ground when it's finished moving down before it starts moving back up again. What time was that? Because we already calculated that. Yeah, the 3.514 hours. And then when is it at its maximum? Look, it starts on the ground and it does what? Goes up. So it's at the maximum when it's finished moving up before it starts to go down again. So what time was that? Yeah, 1.571 hours.